All right. So, in the interest of being able to draw our box plots, it's going to be easier to go ahead and compute everything here. So, very painfully, I determined that there are 40 observations in the men's height chart. So, let's count and mark as we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's our lower quartile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our median. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's our upper quartile. So, working that out, we have 21.5, 22.5, and 24.5 for the men's height quartiles. And so we have 20 as the minimum, 28 as the maximum. All right, so we've got all of the 5 numbers that we need for that. Doing the same thing for the width, we have 13 as the lowest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have 19 as the highest, and then 15.5, 16.5, and 17. All right, so there's all of the 5 numbers we need for that. Now on to the women's. We have, I believe, the same number of observations, but let's just go ahead and count to be sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. Okay, so same number of observations. We have 11.5 as the minimum. Keep in mind, these are in centimeters. That's tiny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that puts us at 13, 14, 15, and 21.5. All right, so same number of observations for the width, so we can just start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so 12 is our minimum. 14 is our lower quartile. 15 is our median. 16 is our upper quartile, and 18.5 is our upper bound. So we now have all of the values that we need to draw our box plots on the next page. All right, so now it's time to actually draw the box plots. And the first thing that we have to do is figure out what our scale is going to mean. So we've got 8 boxes here. We have to span basically from 10 to 30. So what I decided to do was to make every 2 boxes equal 5 centimeters. So start at 10, make this 15, 20, 25, and 30. That gives us a single box is equal to half of a centimeter, which is the resolution of our data. So we should be able to not have to estimate too much to draw our boxes. All right, so we've got the x-axis. On the y-axis, we need to do a men and women. And then height. And width. Okay. All right. So our axes are all set up. And if you look at the video I recorded for the previous slide, we've got all of the 5-number summaries we need. So for each of those distributions, we have to calculate the interquartile range. So starting with men's height. So I went through and wrote down all the numbers because I can't flip back and forth while I'm recording this very easily. But our lower quartile is at 21.5. Our upper quartile is at 24.5. That's a difference of 3. So 1.5 times our interquartile range is 4.5. Which means that our whiskers can go down as far as 17, so 21.5 minus 4.5, or up as far as 29, so that's 24.5 plus 4.5. But our data doesn't extend that far. So what we have is our median at 22.5. All right. So let's make our median there. We've got the the lower quartile at 21.5. Okay, so if each one of these is a half, that's right here. We have our upper quartile at 24.5. So that's up here. So we've got our box. Okay, make that, nice and visible. All right. So I talked through figuring out how far our whiskers go, and our interquartile range actually goes past our data. So we stop at the minimum value, which is at 20. Okay, so there's our whisker there. And then we stop at our maximum value, which is 28. So 26, 27, 28, which is right about here. Okay, and that's just where we stop. So there we go. And there's our first box plot. All right. Now, for the width, we have a minimum value of 13, a lower quartile of 15.5, a median of 16.5, an upper quartile of 17, and a maximum value of 19. So those are the numbers I'm working off of. From that, we know that our interquartile range is 17 minus 15.5, which is 1.5. 1.5 times our interquartile range is 2.25. Okay, so that's the distance we're going to go from either side of our box. Let's go ahead and draw our box, which is starting at 15.5. Okay. So that's the lower quartile. 16.5 is the median. 17 is the upper quartile. Okay, so we've got a much smaller box here than we had before, which makes sense. There's less variation in the widths. We need to go 2.25 in either direction from the sides of that box. So there's 1, 2, and then we stop there. Okay. And on the other side, so our lowest observation is 13. So we have an outlier here. On the other side, though, our whisker would actually extend past our observations. So we're going to stop at 19. All right. So there's our upper whisker there. And we do not have any outliers on the top side. So the really nice thing about, I'm just going to shade this back in so that it doesn't look like an outlier. And shade this one in so that it doesn't look like an outlier. The nice thing about this is it really highlights the fact that, hey, there's this one data point that stands out. All right, so that's really the primary use for box plots, is to highlight that sort of thing while summarizing the rest of the distribution at the same time. All right, so I'm getting bored with blue. Let's go ahead and switch to red when we do the women's pants. All right, so I'm going to start on the height. So we'll just work all the way up. And I'm actually going to go ahead and mark the minimum observations on here just so that we can keep track of them. Okay, so there's the minimum at 11.5. The lower quartile is at 15.5. So that's here. The median is at 16.5. So that's here. Oh, you know what? I was actually looking at the wrong numbers. All right, scratch that. So minimum observation is at 11.5. Then lower quartile is at 13. Sorry. So 11, 12, 13 right here. Our median is at 14. Our upper quartile is at 15. And our maximum observation is at 21.5. So all the way out here. All right. So that'll just keep us from drawing our whiskers too far. So let's go ahead and draw the easy part, which is the box. Okay. And notice that, at least for the middle of the distribution, this is very symmetric, right? There's the exact same distance from the median to the lower quartile as there is from the median to the upper quartile. That's pretty nice. So our interquartile range is 2. 1.5 times that is 3. So we can go below this by 3, but oops, we just hit our lowest observation, so that's as far as that whisker goes. On the other side, we can go up by 1, 2, 3. And that's where our whisker stops. And I did have to flip back to the other slide for this, but we have 2 outliers at 19. Okay, so let's put 2 dots here for that, and then 1 dot at our maximum. Very nice. And then we can go through and erase our little guide marks there. Okay. So from this, we conclude that the height of women's pockets is absolutely pathetic. Sorry, editorializing. All right. So for the width of women's pockets, I'm going to go ahead and mark out lowest observation is at 12. Then we have the lower quartile at 14. The median at 15. The upper quartile at 16. And the maximum at 18.5, which is here. All right. So, start with the easy part, draw the box. Draw the median inside the box. All right. Our interquartile range is again 2. Interquartile range is 2. 1.5 times that is 3. All right, so we can go down, and it looks like we're not going to have any outliers in this one, so we can go down up to 3 units, but oops, we stop at 2 because that's where our lowest observation is. We can go up to 3 units, but we stop at 2.5 because that's where our maximum observation is. And real quick, clean up the guide markings there, and we're done. There are our box plots. So from this, I conclude that the maximum pocket dimensions in women's jeans are grossly undersized compared to men's jeans. The width is, smaller, but not unjustly so. Really, where this ends up causing problems is in the height measurement, where women just get completely shafted. So that is my conclusion, statistical or not. Thanks.